October 2025. As Earth's telescopes fell blind behind the sun's glare, a lone spacecraft orbiting Mars captured what no observatory on Earth could, an alien relic slipping past the red planet at 86 kilometers per second, a visitor carrying chemistry billions of years older than our solar system. China's Tianwen-1 returned the only direct evidence of this ancient wanderer, data gathered in the narrow window when every other instrument in the solar system was helpless. What those few stolen observations revealed now has the world's scientists questioning the story of our beginnings. The weak Earth went blind. In early October 2025, the geometry of the sky created a perfect storm. 3I Atlas passed within 15 of the Sun as seen from Earth, entering the dreaded zone of solar conjunction. Nothing could see through the blazing curtain. Even the world's most advanced observatories from Mauna Kea in Hawaii to the Atacama Desert of Chile were overwhelmed. Their detectors washed white as the comet's dim glow drowned in sunlight. For nearly a week, Earth was shut out. And it happened during perihelion, the most scientifically valuable moment, when exotic ices vaporize and reveal a comet's deepest chemical secrets. Models stalled. Observation campaigns were canceled. Automated surveys powered down. Astronomers could only watch from the sidelines as an interstellar visitor disappeared into daylight. Yet, while Earth was blind, Mars was not. Mars, the one clear window, trailing behind Earth in its orbit, Mars had the perfect angle. From there, 3I Atlas sat safely away from the sun's glare, a dark smudge against deep space. And orbiting the planet was Tianwen-1, never meant for comet science. But suddenly the only spacecraft in the solar system with a clean view. Its camera is designed for craters and dust storms, not for a faint interstellar target 30 million kilometers away. Its spectrometers were calibrated for Martian air, not ancient cosmic chemistry. Still, scientists realized, if Tianwen-1 didn't act, the world would lose its only chance. The gamble at Beijing Flight Control on October 1, 2025, inside the Beijing Aerospace Flight Control Center, Dr. Wu Jianzhu and his team made a high-risk decision. Repoint the entire orbiter away from Mars to chase a target no wider than a small city, moving faster than anything the spacecraft had ever tracked. The challenges were extreme. The attitude control system needed Arxicon precision. The target was nearly 100,000 times dimmer than Mars. Exposure times had to be bracketed on the fly. Tracking algorithms were rewritten mid-mission. Telemetry showed the spacecraft straining at its design limits. A brief communications dropout froze the room. When the first clean image finally appeared, sharp, stable, real, the room erupted. But celebration gave way to frantic verification. Raw data was checked for drift, packet loss, cosmic rays, calibration errors. Tianwen-1 had done it. It had captured an object older than the planets themselves. The spectral shock, chemistry that shouldn't exist, the first spectra were bewildering. After background subtraction and calibration, certain features leapt off the screen. Heavy carbon chains dominating the visible and near-IR spectrum. Strong emission from neutral nickel with peaks near 3,415 Y and 3,513 Y. A complete absence of iron, normally paired with nickel. No water vapor lines at all. This combination is unheard of. Solar system comets show water, simple hydrocarbons, and paired nickel-iron lines. 3I Atlas showed none of these patterns. Repeated checks confirmed the signals were real. Aggressive stacking and artifact rejection kept the faint target clean. The carbon chains and nickel multiplets remained stable across exposures. The comet's chemical fingerprint looked like material formed in environments far colder and far older than any region that produced our planets. Isotopic ratios, a message from before the sun. Isotopic analysis deepened the mystery. Compared to Earth and Solar System comets, 3I Atlas showed carbon-12 to carbon-13 ratios resembling ancient pre-solar grains. Oxygen-18 enrichment beyond solar values. Nitrogen-15 levels consistent with primordial molecular clouds. These patterns match galactic chemical evolution models from 4 to 5 billion years before the Sun existed. This object was not just from another star system. It was likely born from the interstellar medium itself, a relic of the Milky Way's earliest eras. Tronlen-1's images revealed a nucleus about 5.6 kilometers wide, not solid but fractured pieces bound together by dust and faint outgassing. Instead of bright, focused jets of water vapor, the object emitted none. Instead, a spherical, luminous cocoon surrounded the core. Deep emerald green near the nucleus, fading to blue, then violet at the edges. A color gradient rarely seen in comet science, likely caused by exotic hydrocarbons or nickel ions fluorescing in some light. The nucleus itself was extremely dark, with almost no reflectivity, ancient material blackened by cosmic radiation. There was no obvious rotation, no tail, no water-driven activity, just a drifting, color-shifting envelope around a shattered core. A sight unlike any comet ever captured. Interstellar objects now come in 3 forms. Oumuamua 2017, no coma, elongated, dry. Tuai. Borisov 2019, classic comet tail, water-rich. 3I Atlas 2025, fractured, glowing halo, exotic chemistry, water pore. Atlas doesn't resemble either of the previous visitors. Its form is like its chemistry alien. Scientists now suspect that the diversity of interstellar debris may be far wider than imagined. At the Max Planck Institute and Harvard, teams are tearing through Tronlen-1's calibration files, checking each pixel for bias and drift, running independent spectral reductions, cross-matching atomic lines with lab standards, comparing instrument responses to Mars Express and Hubble. For main theories are under review: primordial relic of the early galaxy, shattered fragment from an ancient planetary system, chemical survivor from extreme cosmic environments, prebiotic material carrier speculative. Every claim must survive open critique, cross-calibration, and replication. China at the center of a new cosmic era. For the first time, the Chinese National Space Administration holds exclusive in situ data from an interstellar object. This achievement brings admiration but also diplomatic tension. COSPER panels now debate who owns interstellar discoveries. Should data be shared openly? Will future missions be collaborative or competitive? Meanwhile, NASA, ESA, and CNSA quietly began drafting concepts for a joint sample return mission, the first attempt to physically retrieve material older than the Sun. A final reflection: 3I Atlas is more than a visitor. It is a messenger from a time before planets, before the Sun, before Earth. As its fractured form drifts out of the inner solar system, it leaves behind a challenge. Science advances not by who detects first, but by what humanity chooses to share. The galaxy's oldest travelers still pass silently among the stars. And now, for the first time, one has spoken.